torque example, chopsticks. Chopsticks are one of the best inventions of Chinese, well, at least for eating. Instead of using two hands with knife and forks, it can be used only one hand. But is it really easier to use chopsticks? Let's prove using the torque formula. This is a chopsticks, which can basically be analyzed into a lever. So this is the fulcrum. And from that, there's the radius distance 1. And there's the perpendicular force number 1. Here's the radius distance number 2. And when we add something into it, it creates the force number 2. Net force is equal to force number 1 times radial distance number 1 minus force number 2 times radial distance number 2 toward the direction of the greater force. This is the formula that we studied. Radial distance number 2 is greater than radial distance number 1. So if you apply the same force on the finger, the force number 2 is greater than force number 1. So the torque number 2 is greater than the torque number 1. So it takes more force to use the chopsticks than knives and forks. Let's take a look. This is a picture of the knife, and those two are the fulcrums. These are the force number 2. The radial distance of it is equal to 0. This is radial distance number 1 and the force number 1. It is easier to use forks than knives because the radial distance number 2 is smaller than radial distance number 1 times force number 1. Let's take a look at centripetal force. This is an example of a Ferris wheel. These are the forces pulling against it. This is force number 2, which is the tangential force. This is force number 1, which is the centripetal force. This is another example of force number 2. So the rotational speed is 60 minutes per rotation. Thus, the tangential speed is equal to the circumference times the rotational speed. If the radius is 100 meters, the circumference times the rotational speed is equal to 628 meters times 60 minutes per rotation, which is equal to 628 minutes per hour. Thanks for watching.